Okay, everyone. Thanks for coming to this talk. I'm super excited to tell you about semantic search over the web. And thank you, Jason, for inviting me to this. Yeah, as you've heard, he's a longtime friend, um, and yeah, great guy. And so yeah, I'm super excited to tell you about semantic search. The best, in my opinion, the best presentations are stories. So I'm just going to tell you a story about Exa and the way we think about search and how it's evolved. And I think through that story, we'll learn a lot of cool things. And then we can have questions at the end. Okay, so like any good story, let's go back in time to 30 years ago. So the year is 1998, and Google feels magical, right? I don't know, probably a lot of people on this call weren't around then, but in 1998, when you typed in Australia to Google, you would actually get like the homepage of Australia, australia.com, and like the Wikipedia page for Australia and other like really high quality resources. And this to people was magical because unlike previous search engines like Yahoo and Ask Jeeves that could also handle keyword search, the big insight with Google was PageRank, this algorithm that like looked at the structure of the web and which websites link to other websites, and they were able to figure out like what are the highest quality sites. And so this was the the state of the art of search at the time. Okay, let's now skip in our story to 2021. Well, now in 2021, GB3 felt magical. It had recently come out, but Google felt ancient. So I remember playing with GB3 in 2021, and I would type in like a sentence or a whole paragraph, and it would understand the subtleties of my language, of my paragraph, and then it would respond exactly with a response that like really understood what I was saying. And it was amazing. And then at the same time, we had Google, where I would type in like a simple query, like why to start a succulent garden. And it would not actually return me things that match exactly what I said. It would return me like how to plant a succulent garden. And that's just one example of how like Google wasn't actually understanding the subtleties of my language at all. And so the insight was like, wait, what if we could build a search engine that understood language as well as GB3? Like, what if we could have a search engine that understood me and understood the web and could return exactly what I wanted? I was super excited about this idea, and we were like, okay, let's go build a company to do it. And so we went to Y Combinator, we raised some money, and then of course we spent half of our money on a GPU cluster, as every startup should. I'm just kidding, but we got like 80 A100s. This is what they look like. It's pretty cool. They're still running today. And the goal was like, hey, like Google's algorithm, it's great for certain types of things, but not for complex queries. What if we could train models, train AI models like LLMs into the search algorithm itself to like understand more complex queries? And so it was like a neural approach to search, the search algorithm, as opposed to a keywords approach that like with Google. And so basically we did research. We just, went heads down for like a year and a half, just like banging our head against the wall of this problem, like trying out all sorts of different architectures, like transformer-based architectures towards search, reading tons of papers, like making tons of data sets, failing a bunch of times. And eventually we actually here's just some training curves. This was, I think, the training curve that was one of our models that actually worked really well. We tried this new technique, and it was like it suddenly worked. We were able to like take text and predict links based on that text using a fully embedding-based approach that no one had tried before, and it was magical, and we were super excited. And we launched it in November 2022 on Twitter, and a lot of people felt like this was like the next generation of search. Like, for example, someone said like, this is the first time I felt there's been a step change in search since using Backrub in the late 90s. And that was a beautiful comment. Nat Friedman liked it. Okay, so that was November 2022. And a couple weeks later, this happened. So a pretty small tweet, like today we launched ChatGPT, try talking with it here. I actually didn't, at the time, I didn't think it was that big of a deal because I had been playing with GPT-3 all the time. But to the world, it was a huge deal because it was the world's first interaction with LLMs on a large scale. And this is a visual depiction of San Francisco at the time. The world was, the whole like software world was going through this tectonic shift because like the way we get information seemed to be radically changing. And this is a visual depiction of the Exa team at the same time. We were building search, and suddenly the entire information ecosystem was shifting and going through tectonic shifts. And we were thinking a lot about like, okay, is search even needed? Like, what is search in this new world where these AI systems can just like return you, like can interact with you in all these crazy ways? And we quickly realized that actually search is extremely needed in this new world with LLMs because LLMs haven't memorized the whole web. So if you ask an LLM, like find me cool personal sites and engineers in San Francisco, the LLM is just not like GPT-4 would not be able to return you results that match because it hasn't memorized all the personal sites of engineers in San Francisco and like organize it in its head that way. There's a cool like information theoretical argument you can make here where just look at the number of bytes in GPT-4 and the number of bytes on the web. So like GPT-4, maybe we don't know exactly how many parameters, but probably like a couple of trillion parameters. Each one's maybe a couple of bytes. It's less than 10 terabytes. But the internet is trillions of documents, and that's like millions of terabytes, and that's just text. And then when you go to images and video, obviously you go like crazy big. So like the LLM simply cannot memorize the entire web. It has to do, if you want to ask it about the web, it can't, it has to use retrieval. Okay. And so one cool thing I tried here once was I looked at Wikipedia articles of people ordered by popularity. So like, let's say Albert Einstein was near the top. And of course, LLMs know the birthday of Albert Einstein. They've memorized that because they've seen him many times. However, if you go to like the 20,000th person, like some soccer player, it's not going to know the birthday of that person. And so you realize that like LLMs, they seem like they memorize a lot, but actually the web is gigantic. It's really, really big. But when you combine an LLM with a search engine like Exa, you could actually do much more powerful things like find me cool personal sites of engineers in SF. And it actually, it searches Exa, gets personal sites, and then it analyzes all that content and gives you a personalized response. Now this was kind of, in 2022 days, this was kind of like innovative. Now everyone knows that search plus LLMs is super powerful. It's a super hot topic. I think what people don't realize is what type of search LLMs want. And this is like an interesting insight that still hasn't like proliferated. And the insight is that like traditional search engines like Google and Bing, they weren't built for LLMs. They were built for humans. And LLMs are very different. So like humans, this kind of looks like the way you would search on a search engine like that, this GIF. Like humans want to type simple keywords because they're lazy. They can't type full sentences, and they want to find like one, maybe a couple links because they're not going to go analyze a ton of information. And so Google built a keyword-based algorithm for humans. It makes a lot of sense. Like Google built a search engine to handle their consumers, and they did a great job. The thing is though that like AIs are very different from humans. And if you want to build a search engine for AIs, you should do things differently because AIs, they don't use simple queries. They're not lazy at all. They could instantly output a complex query specifying exactly what they want. And they don't just want one link. They want like tons of knowledge. Give me all the knowledge because they could just gobble it up instantly. And so to make an optimal search engine for AIs, you really should use a different algorithm than Google. It would kind of be actually insane if the same search engine that was optimal for humans would also be optimal for this very different creature. And so when we actually realized that when we were building our new search engine called Exa, it was actually pretty perfect for this new AI world. Pretty lucky. And let's just go through some examples of like more specifically like why AIs are different from humans in terms of what search they want. So one, like AIs want precise, controllable information. So by the way, when I say AIs, I'm talking about like AI products that you guys would all build. Like if you're building imagine you're building like a tool for VCs to find and analyze like company information because they want to go make deals. Well, when the VC asks the AI like, hey, I want to invest in something like huge, something that feels like Bell Labs. Well, then their AI tool would then go and search a search engine, and it wants to find startups working on something huge, feels like Bell Labs. The problem is that like search engines like Google, they don't actually give you exactly what you asked for. They kind of give you the kinds of things that humans click on. Like this is a great result for humans. Humans click on Reddit. People like reading Reddit. It's a cool UI, or Quora, and like looking at the information inside that. But actually, LLM just is like, give me the information I asked for because I said I want startups working on something huge. So give me a list of startups. Give me 10. Give me 100. Like it needs like a search engine that actually respects exactly what it asked for. So like the AI would search for startups working on something huge. It would get a list of startups. And then maybe it would look for like, hey, give me people's profiles that are working on something similar because I want to talk to them. Okay, well then the search engine should be able to do that too. So what you want is a search engine that could like repeatedly return exactly what the AI asked for, as opposed to like a search engine that was like optimized for what humans click on. Hopefully that makes sense. So that's just one example of how AIs are different than humans. Another way AIs and humans search differently is that AIs want to search with lots of context. If you have some AI system inside your product and you ask it some question, it has a ton of context on you and the whole conversation. Like let's say it's a chat, it has the whole chat as context. Like you should be able to search with all that context. The problem with current search engines is they can't, like traditional search engines like Google, is they can't handle queries that take in like multiple paragraphs. Like they literally have keyword limits. They're keyword search engines. And so they'd have to convert your complex context into keywords, which loses a ton of information, search those, and then return that. That's very inefficient. That's not optimal. That's not how you would design a search engine if you knew you were building it for AIs. Whereas Exa can actually handle like long context queries natively, because, and we'll talk about like a little bit how Exa works and why we could do this. But and so when you ask for like, this is in this query, it's like some text from the GPT-3 paper, and like find me some similar papers. So find me papers with similar ideas, and like Google will just return like the same paper multiple times. That's not what you want. That's not what you asked for. Whereas Exa would return actually like similar papers to GPT-3. So AIs want to search with lots of context, bigger queries, long giant queries. Another way that AIs and humans are different is AIs want comprehensiveness. Like humans, when they search, again, they want like a few links because like humans are lazy and they don't have like infinite capacity to analyze information. But an AI does. We now have these systems like test time compute systems like O3, right? That could like just gobble up tons of information. So you need a search engine that exposes that to the AI. So like, for example, if you're the VC and you say, hey, give me every startup funded by YC working on AI, and also give me all the information about them, like batch and status. Like you need a search engine that can handle that. Like traditional search engines were not built for the system, and to build something that could actually give you like thousands of results, you need to design it differently. And Exa actually can do this. Exa can do this. So those are a few of the ways AIs are different. I think when you think about it more, you'll realize that AIs are very different, and it's just a completely different paradigm. And so if you want to build a search engine for AIs, you should build it differently. I think more broadly, one interesting way I've been thinking about just like search as a whole is that the space of possible search queries is very broad. And like traditional search engines like Google have trained us to only think about this, like if you see on the top left, this like keyword bubble of like the space is the gray zone, like all the possible queries, and the blue is like things that the tools can handle right now. And so like stripe pricing over here on the top left, that's like Google has trained us to search like that, right? But there's actually like many different types of queries that people might want to make that go way beyond what Google can handle. And I think ChatGPT was very like showed the world this, because like their ChatGPT like queries are very, very different from Google. You might like paste your entire code error and say like, hey, find me places on the web where people have had this problem and how they solved it. Like that's a query that's very different. And if sometimes I forget and I paste that into Google search and it like just can't handle it because it's not it wasn't built to handle like these like long paragraph queries. And so like those are like a ChatGPT like queries where it's like, explain this to me, or any sort of way you interact with ChatGPT. But then there are also all sorts of other queries that like ChatGPT can handle. So like semantic queries on the left side, it's like people in SF who know assembly language. That's like a semantic query that neither Google or ChatGPT can handle. And actually Exa is quite good at those. And then there are lots of more queries. So there's like super complex queries I've labeled on the bottom right, which is like, find me every article that argues X and not Y from an author like Z. And you can fill in the blanks. But you never even think to search this, right? Because you know that search tools can't handle that. So like when you think search, you never think of this. But actually, if search tools could handle that, you would search these all the time, because you would have like, you would be able to analyze the web like in any way you want. And it would be magical. And then just more broadly, like at the bottom left, there's like just the queries that no one has even thought of to try yet. So I'm very confident that there are many, many types of queries that go beyond the ones listed here that we haven't even thought of because our tools can't handle it. And as we build the tools, we think of new queries, similar to how like as LLMs get better, you think of new ways to interact with LLMs. I think the space of possible search queries is very broad. I think that's a really important takeaway from this talk. Okay. And so just the way we think about Exa in this space, because there's a lot of like there's a lot of like information, like, there's a lot of noise about like search right now. It's a very hot topic, and it's like I think it's helpful to have this like just like picture in your mind of like where Exa stands. There's like the search infrastructure companies that actually, like Google, Bing, and Exa, that actually crawl the web and index it and process it so that they could expose, like, so that you could like get information from those indexes. And then there are the AI applications that build on top. So like Gemini is actually an AI app built on top of Google. It's like an LLM built on top of Google results. And like, so Gemini will repeatedly call Google. And similarly, like SearchGPT will repeatedly call Bing, and like other AI startups will repeatedly call these search engines. So like Exa is trying to be the search infrastructure, and we want to be able to handle all these possible queries. That's our goal. We're not all the way there yet, but we're doing, we can handle a lot of these. Cool. And just like just more clearly how Exa fits in, you would have like some AI app on the left side. Whenever your AI application needs some information from the web, it should form a query, send that to Exa. Exa's connected to the web. Exa sends back information that's most relevant to that query, and then you go use that information in some downstream processing. And our goal with Exa is like expose the best possible API, like allow your AI to search whatever it needs, like whatever toggles or filters it needs to get the information it wants. Okay. Okay, and so now hopefully that you understand the space and our goals. I'll talk a little bit about like how Exa works on a high level, and then we'll dive deeper into one of these components. So yeah, I mean, when you're building a web search engine is not for the faint of heart. It's pretty hard. Everything is massive scale. But here are the basic components, right? So like first, you got to gather your URLs to crawl. The web is massive. It's trillions of URLs. At least right now, X is not going to get all trillions, but you get some large subset of those URLs to crawl. Then you have this like distributed crawling system to go crawl them. And there are like different formats and stuff like PDFs and stuff like that you need like, complex crawlers to handle. And then you need to then just simply store it. And like even just thinking about the way we store things is super important, because if you store it incorrectly, it's going to be really annoying to do like all sorts of batch jobs over petabytes of data. So we use S3, and we thought a lot about our storage format. And then we, okay, so now you gather all these documents. That's the easy part. Now you have to process those documents, pre-process them into a format such that you could retrieve over them later, right? In like the Google case, or let's call it the 1998 Google case, they would like pre-process the web into like a PageRank score and like a list of keywords that are contained inside that document. That's a pre-processing step, and then that allows you to do fast retrieval at search time. X's approach is different. We use embeddings, so we'll take your documents in the web and embed them, and then so that's the pre-processing is converting them into embeddings and various other formats. Okay, then once you have this, like you've pre-processed all the documents into some format, you have to put them inside a database. So ingest into so in our case, we ingest into a custom neural database that we built. Okay, now you have this database, and now you of course have to serve it to users, and it's a massive database, and you could have very high volume users, so that's pretty complex to serve that too. And like clouds are not very easy to use GPUs on sometimes, so it's kind of complex. But and then okay, so that's the whole system, and then you serve that to your users. So that's a general like broad overview of Exa system. Each component here is quite complex, and so I wanted to dive into one of them, this like Rust-based vector database. So over here, I guess you can't see my mouse, but I'm hovering over that one. Cool. So diving deep into this database. Okay, so what is the goal here? So Exa processes these documents, and we use an embeddings-based algorithm. So we take each document and run it through an embeddings model that we've trained, and it outputs an embedding. An embedding, a vector, the same thing. It's a list of floats that capture the meaning of that document. And there's a lot of secret sauce that goes into an embedding model that's really good at like precise pre-processing of documents such that they can be retrieved well. But I'm more interested here in after that, where we actually get the list of floats from each document. So we have billions of documents, and we have billions of lists of these embeddings. And now when a query comes in, you have to embed the query and compare it to each of these embeddings of each document embeddings. So you have billions of embedding comparisons, and that's extremely slow. It's also really expensive to run. So we have this problem of like, it would be ridiculously expensive and ridiculously slow if we just did a naive like cosine similarity between the query embedding and the document embeddings. So how do we make this faster and cheaper? Okay, so and also there are like vector databases to build this kind of stuff, but we decided to build our own because well, one, like any sort of performance gain we make would actually save us a ton of money, so it made sense for us, and we were willing to like build versus buy. But also because we don't just want to do embedding search, we want to go beyond just simple embedding search, and we already have. And so it was the right call, because now because we control our own vector database, we could build on it in all sorts of crazy ways. So okay, but here if we're talking specifically about the embedding search, so there are a few techniques that make this embedding search faster and cheaper. So here are four I've listed, the four major ones. So the first one is we use this training paradigm called Matryoshka, which when we train our embedding model, well, what we do is we train our embedding model to output an embedding, but also the first half of that embedding should be a good representation of the whole embedding. Meaning, if for some reason we cut our embedding in half, and we just took the first half, that would be a pretty good approximation of the whole embedding. And then actually, again, if we cut that half into a quarter, that quarter would also be a good approximation of the whole embedding, and so on. So like we would have, what we get is like an embedding that inside it contains different embedding sizes that each are a good representation of the whole embedding, kind of like a Matryoshka doll. That's where the name came from. And what this is helpful for, because we don't actually have to serve the full embedding, which would be too slow, we would use the lower dimensions, maybe like the 128 dimension vector instead of the 1024 dimension vector, and we'd serve that, and it would be an approximation of the full vector. All these methods, by the way, they're approximations, because you could literally calculate the amount of like operations you have to do a full embedding search, and it's just not tractable. So you have to do all sorts of clever approximations, and you do that because because like the vector space is not actually like perfectly random. Okay, so Matryoshka is one method where you could compress the vectors. There are other compression methods, but Matryoshka is just, we found, really good. Another technique beyond Matryoshka is like, let's say once you have these compressed embeddings, now what you could do is you could cluster them. And you can see here on the top right, there are like different clusters of embeddings. One might be like, it's actually cool. We could like look at the web, and we've like clustered the web and looked at it visually, and you see like all the archive papers are on the top left, and like all the blog posts are on the bottom, and the math blog posts are like within that cluster. And it's like you can actually like kind of like project the web onto a 2D space into clusters. And the clusters are actually multi-dimensional, like many hundreds of dimensions, but you could you could like cluster these embedding vectors, and then when you do a search, you could only search over the clusters that are closest to your query. And so what you're doing is you have like 1,000 clusters. Let's say you only search over the top 3 clusters. You just save 300x in terms of speed. So that's ridiculous speed up. But again, it's approximation, but it's pretty good. Another one we do is even still using 128 dimensions or whatever it is too much. It's too big and it's too slow. So what you could do is at the bottom left, you see we convert it into Booleans. So instead of having floats, we just convert our floats into Booleans. And so now it's like a very approximate. It's shorter and Boolean, so it's super approximate, but it's extremely fast. But even then, it's too slow because like when you're doing over billions of documents, billions of binary compressed embeddings using clustering, it's still too slow. And then so a lot of the advances or the speed ups we got were from like going into the actually assembly and like the SIMD operations on the like low level stuff on the CPU to like really optimize it to just get all the juice out of this system that we could. We have a blog post on this if you want to see more detail. But I think, so that was just like I wanted to highlight that component of the system because that's just one component of our whole system to build this to make it work. And every component is like pretty crazy and complex like that, because when you're doing things at massive scale, you just have to deal with all these questions. Okay. Let's see. Okay, so I thought I would then share just a quick example of, so we have this like Exa system, like maybe just a quick how you could use it in your oh no, my API keys expired. How you could use it in your system. Okay, let's go to I thought it'd be cool to like, just by the way, like, so we have a dashboard and we have like different routes you could use to search. So all sorts of different routes. So there's search. Actually, let's just go to the homepage, and we have this cool nifty thing where you can actually just talk to your LLM about how to use Exa. So I would say like, build me an app to do similarity search. That'll just be helpful for explaining things. So actually, like the LLM it has all the, it uses RAG, like local RAG. It has all the documentation in its context window, and it will just tell you how to use the X API. And so you guys could just use this to find information, like find similar results or search in various ways. I guess I just want to highlight here, like this is the place where you could do searches. I'll just run the search. So you get a list of results, like all the data you want. I think that what's interesting is the philosophy here is we want to give users like full ability to toggle the search engine however they want and create their own really like customized search engine. So for example, you could choose obviously the number of results, but like different date ranges and domain filters, and even things like categories, like maybe you only want to search over companies or research papers or news articles, or maybe you don't want news articles and stuff like that. And so we want, the philosophy here is we want to give users full control, give the AI systems full control to get whatever information they want. It's a very different philosophy from like Google, which is like, hey, all consumers are kind of similar. We kind of like want to like abstract away all the complexity. But I think because we're serving like businesses and products, we want to like actually let you toggle it. Anyway, I won't go too far deep into this, but like a recent endpoint we've released recently was this like answer endpoint, which is pretty cool. Like instead of often like AI applications, they don't just want the results themselves; they just want like a quick answer. So you could do that, and you can get like a streamed answer. Pretty cool. Okay, let's go back to the presentation. Okay, so that's how we expose our search to our users. Okay, so getting closer to the end now, it's helpful to think about where we're going. So like the goal of Exa really is perfect search. And what that means is we want to be able to handle everything, like every possible query. And I think when you start looking at actual examples, it becomes a lot clearer how cool this is. So I wrote a blog post recently where explaining like what does perfect search mean? And so just I thought it'd be helpful to go through some categories here. So like, what does perfect search for people mean? Well, it would mean you could do things like, hey, I'm creating a Discord of best prompting practices. Like, find me anyone who's ever thought deeply about this on the web. Like, can you do that right now on search engines? Like, no, you can't. But if you could, then you would be able to create communities on the fly, and it would bring the world together in beautiful ways. Or like, who in Berlin has written about new search algorithms? Because I'm going to Berlin. It's like Jason would love this, like, right? Like Jason would meet up with people. Okay, that's like perfect search for people. Or like, what about I had perfect multimodal search twice. That was an accident. But okay, what would perfect multimodal search mean? Okay, well, it means like if I want to find images of shirts without stripes that have a cool mix of colors, like a Jackson Pollock, I should be able to do that. But actually, with like traditional search engines like Google, if you search like shirts without stripes, like images of shirts without stripes, you'll actually get shirts with stripes, which is crazy. You could try this out on Google. Shirts without stripes, you'll get shirts with stripes. And the reason is because it's doing keyword-based search. It's not doing like a semantic-based understanding. And so, yeah, there are other things you could do, like perfectly curated music. I would love this. Like, find me Hans Zimmer like music with a fast beat similar to the song Supermarine, which is a great song. Like, you can't do that right now. So there are all sorts of searches that you would be able to do if you had a perfect search engine. Or you could do like crazy analyses, like at the bottom right, like search like analyses of X of like some topic by liberal authors, and then analyses of that topic by conservative authors, and then analyses of that topic by conservative authors who used to be liberal. Like, you'd be able to like control the information you find in all these powerful ways. And I think people don't realize how much like more like the world's knowledge would actually be in your head, like at your fingertips. It's still a little abstract, I think, like, but hopefully these examples help you see. I think one really interesting insight here that is definitely true is that perfect search requires test time compute. So like all these queries I just mentioned, these complex queries, there's no way they could return in half a second like traditional search engines we're used to, because they're just too complex. They require more compute. And very similar to how LLMs require, like for simple things, you could use GPT-4o, but for complex things, you need O3 because it just like it fundamentally is a hard, it's like fundamentally hard search. And so like Exa is really thinking a lot about like test time compute search. So what does test time compute for search mean? Well, it means your search could sometimes take half a second, but sometimes it could take a minute or 10 minutes or an hour or a day for super complex things. And of course, we want to optimize that as much as possible, but it's just fundamentally a hard problem. So, and we have this new product called Websets that tries to address exactly this. So like, for example, if you want, find me research papers about cell regeneration technology co-written by an MD and a technologist, like that's a hard query. We could actually handle it pretty well, but it'll take some time to get all the results. So if you want 20 results, it'll take a minute. If you want 1,000 results or all the results, it might take hours. But for certain queries, you're willing to wait that long. So this is a very different paradigm for thinking about search, this test time compute search, and it is the way to handle to get the perfect search. Okay, and then I'm just like now in our story, we started in 1998, maybe 30 years later. Is search solved? Is this gray zone completely filled with like some tool that can handle it? I don't know if 2028 is the. I would say like 2028 search will be amazing, like magical, and we'll look back on 2025 and we'll be like, oh my god, they didn't know anything about the world. I still think that there will be many different things to go beyond. Like after 2028, there'll be many different types of searches that will still not be possible because search is a very broad concept. It's not even just web search. It's search over any information. That might involve like satellite data and like data that's not on the public web. And so I think this is a beautiful mission that will last a long time. And similar to like LLMs and intelligence, it's like no matter how good your LLM is, you could always do better. I think similarly, no matter how good your search is, you could always do better. Okay, and that is the presentation. I hope that was interesting.
Oh, great. I feel like I learned a lot more about sort of the mindset that you guys have when tackling search. I definitely need to do some website work now. Like do some
Nice.
marketing, hire some people.
Well done.
Um, a lot of fun. I guess I would love to ask one question particular on building these systems. But I think probably now I've spoken to Glean and you guys, and I feel like you two have done the most work in building these sort of horizontal search systems. I think there's a lot of people here who are building like very much like vertical search systems. Maybe it's over vertical medical records, maybe it's over, legal documents, etc. Um, how do you think they should prioritize their development? It might not be they should fine-tune their own embedding models. It might not be they should build their own vector database. But where do you think the low-hanging fruit is in terms of building these search systems?
I see. So if you want to build like a system over like all like 100 like 200 million research papers, what's
Yeah.
the right way to go about it? I think the search problem becomes easier, of course, like the
Yep.
fewer documents you have, and you don't have to use fancy techniques. Like when you're trying to do search over tens of billions of websites, or hundreds of billions of websites, it's a very different problem. It's a very different beast than searching over 200 million research papers. So, I mean, the hybrid approaches of like combining keyword methods and embeddings-based methods
Mhm.
are pretty good for most things. I think it depends. You have to think about your query distribution. Like, are your queries like simple ones? Like, if you're doing research paper search, it's like GPT-3 paper, or is it complex ones like what's like a paper such that people have this experiment set up that feels like this other setup? Like if you're doing more complex ones, you're going to need to potentially train your own models. I think for a lot of use cases, it's like a simple keyword plus embedding space system could work pretty well. Yeah,
And then I guess another question would be like, how about things like query expansion or, like where, like if we had like 3, 6 months to build something, like what would be the kinds of experiments you would be running or pushing these teams to run?
I see. Yeah, I mean, you could get pretty far these days with uh like query expansion, meaning like you take your query and then you like expand it into like hundreds of words and then search a keyword base with all those words and then get the top results and re-rank. Like that's another technique that would work well. I think it depends on I mean, yeah, that works quite well. Again, like that will not be as good as like these like semantic type queries, but it should work pretty well for a lot of things. Yeah.
Cool. Let's jump into a couple of the upvoted questions and then we can do some live questions in the end. I think a lot of people are really curious, like how do you see yourself different from companies like Perplexity or even just like the generic ChatGPT plus search?
Yeah. Well, I think there aren't too many. Again, it comes back to this like this slide. It's like we think of ourselves as search infrastructure. There aren't too many companies that are actually like crawling the web and providing like a search over it. I think the word search has been used in many different ways. Like SearchGPT uses search infrastructure under the hood. So like Exa can power all the systems, right? Like we want to be search infrastructure that powers all these applications. Um, uh, and so that's kind of like where we stand. I think our big insight is where we like as I've said in the talk, like we believe that current search engines aren't good enough. Like a lot of people are okay like wrapping. Well, they used to like use Bing API, but that's being deprecated. But like a lot of people are okay with like the Bing API. But actually, like a lot of people aren't because again, like AI applications are very different from humans, and so like we believe that there are tons of companies, and we started to see this that like tons of companies that need like search that goes beyond the things like the Bing API. So we just want to be like an API that is just the most powerful one, the most customizable one, and power all these applications that you guys have mentioned.
Uh, is there going to be a Exa deep research tool coming out soon? I realized that, when I try OpenAI's deep research, it might cite like 70 documents, and when I use Claude's deep research, it cites like 1,000 documents, which I was actually pretty impressed with. But I think when you shared a little bit more about your, search for humans is very much like mean reciprocal rank optimized, whereas like search for AI is actually, I want to be able to use all 1,000 documents. Um, like where do you think Exa's position is relative to things like deep research?
Yes, I would say tuned for that. I think we kind of we've really been focused in the past on like the search infrastructure part and like expected others or hope that others would build on top of that. I think what we found is like we could actually build these applications too, like deep research on top of our search. And so yeah, I would stay tuned. A lot of cool releases coming in the next few days and few weeks.
Exciting. I'm excited to start paying for one more deep research. That's going to cost me $200 a month. Um, yeah. Does Exa have any plans on doing things like audio, visual, and video, like audio and visual models? I feel like you mentioned things like playing songs or whatnot. I think that's pretty
Yeah,
interesting.
for sure. I mean, again, like our goals are we want to be perfect search over the web and beyond. And so like all that is part of our mission. I think as a startup with limited resources, we have to be smart and clever uh like we have to be ready for when we have enough resources, we could go do images and videos because they're a lot like the storage costs would go insane. Like our
Yeah.
AWS costs are already insane. And so we will definitely do it. I would say not this quarter, but at some point soon. Um,
Um, this is a funny question. How does Exa figure out things behind paywalls?
we don't. We search over things that are not behind paywalls.
Oh, okay. So I guess there's like maybe the solution is like doing it's like partnerships like OpenAI does, but that
That's right.
feels
That's right.
a different set of business problems. Um, oh, this is an interesting question. As content creators, how can we make sure that our content gets indexed in Exa? Is there like such a thing as like SEO in the this new world? Is it just prompting myself to say like, put this number one?
I think, yeah, no, it's a good question. We don't have like a formal system for that yet, but I think like there will be like SEO for AI systems. I think it's a fascinating space because like, what is SEO? Like, well, often people think of SEO in negative context. It's one thing that's beautiful about Exa is like we could actually because we train our model. So we've optimized our system to try to return high quality information. So we actually typically avoid SEO. So in a way that Google doesn't. Um, and but we're not big enough yet where people are trying to like super optimize for our system. But let's say once we get really big, people are going to be like, oh, how can I hack Exa? I think it's like a lot harder, I believe, to SEO hack Exa because it's an embeddings-based neural search algorithm as opposed to like hacking like a keyword-based algorithm like Google. So hopefully we're more immune to SEO. I think also just like LLMs are smart enough to know what is SEO and what's not. And so you could just like classify things as SEO or SEO not or not SEO and just like remove those. I think Google has like weird incentives where they actually like don't want to remove things because they make more money from it. But like we're very much incentivized just to give you the highest quality information. Anyway, it's a little different from your question of like how do you add stuff? We don't have a
Yeah.
full system yet, but we will.
Yeah, because I imagine right now, SEO really is about getting the click, but there's no click happening in the Exa loop. It's like maybe whether or not data is being cited, but then you have to like own the model that does the citing.
That's right.
Uh,
I think the whole ecosystem is like shifting, and it's like that SpongeBob clip, and it's not clear how things will turn, how the dust will settle. But I think all these things are on the table. Yeah.
Makes sense. Makes sense. Um, Now that the person asks, why not train an embedding model to begin with rather than using the Marioshka embeddings?
Why not train? Oh, embedding model to
Yeah, yeah, yeah.
compressed. Yeah, you could do that. It's a bit of more just like it's annoying. Like you don't know what size you will use in your vector database. And so if you train a model on for one dimension size, then you'll have to like retrain it to be a different size. You could do that though. Also, a nice property is if you have, let's say you have, so one thing we do is we search over the compressed vector, and then so then we get like some candidates, and then we re-rank using the full vector because you get like imagine you go from
Hmm.
a billion things to 100 using compressed method, and then you take your 100 and look at the true embedding size, full embedding, and then re-rank to like to get the top 10. And if you did that with the methods this person's proposing, you would have to have two different models to output two different embeddings. That would be 2x inference costs. So it's like it also saves you inference costs because you only have to pass the document through once.
Got it, got it. Oh, interesting. So you just use the larger embedding to re-rank. Do you have separate re-ranking models? Like for example, Cohere has the embedding model, but then they also have a cross encoder that does
Yes.
re-ranking. Here is, I
Yes,
guess,
we have.
three layers, two layers?
Yeah, we have multiple layers. Yeah. So like every the optimal system, and this is I think fundamental to search is like you do keep doing like lower like you keep doing different techniques as you filter from a trillion things to a billion to a million to 1,000 to 100. You should just like uh use different techniques at each layer. And so it's optimal to use like a super approximate thing to get from a trillion to billion, then a less approximate method to get from a billion to a million, and so forth. So the binary embedding, sorry, the compressed embedding and Matryoshka embedding to the full embedding, that's only one part of that pipeline.
Got it. Okay. Yeah, I guess, top 50 over a trillion things might not get you a very good recall.
Yes, exactly.
Cool. as I go over some of these questions, feel free to like use the Zoom's like hand raise mechanic if you want to ask a live question. I think we got like 15 minutes left. Um, let me see. Oh, how much synthetic data generation do you do for things like creating complex search queries?
I think this is critical. Like the data we train on is obviously like everyone knows that it's like super important. Synthetic data is something we have done recently and have really good results.
Mhm.
So it's pretty important, yeah.
Yeah.
Especially for like the out of like super out of distribution. Well, it's out of distribution because no one searches that way, right? It's like
I see. So you're kind of breaking out of the blue bubble within this like, huge
yeah.
universe
No,
of
like all the LLMs have discovered, a lot of the techniques that like the LLM companies like OpenAI have discovered apply really well to search too. We have similar methods, and so like this whole like O3 teaching itself by trying out lots of like asking itself questions and then solving them and then teaching based on that. Like we use similar techniques. We're just getting started, but it's pretty excited. Pretty
yeah,
excited.
yeah. I'm excited to see the blog posts. I feel like yeah, you're definitely getting probably weirder queries out of some of the other search companies.
That's right.
Like, most of my perplexity searches are like recipes or like how to do instructions. And for you
Right.
guys, it's like I want every YC batch company that's raised less than 10 million who's looking for a head of AI.
That's right. That is it.
Exactly. Do you handle things like authority and recency within the model? Do you also have, I guess another way to ask this is, do you have re-rankers that use additional metadata, right? Like authority, relevancy, recency.
Yes, for
How does
efficiency
it
for efficiency purposes, it's better to bake that into the embeddings model because
Mm,
like okay, one way to think about it is like if your let's say your embedding model didn't have any notion of authority, then when you filter from 1 trillion to 100, none of them are authoritative. So even if your re-ranker is the best authority re-ranker ever, it's not gonna do anything. So you got to bake it into each stage as much as possible.
I see.
But
That makes
authority
sense.
is a hard problem. It's also, I think what's harder about this is the subjective problem. What is authoritative?
Right.
And like I think solving the philosophical problem might be even harder than the technical problem, which is crazy.
Yeah. Yeah. I guess when I think about it, I mostly think about it in terms of like searching internal documents where Glean's example is, the Wi-Fi password is a 7-year-old document, but it's the most authoritative thing ever because it's being at referenced a bunch.
Right, right,
But I guess on
right.
the internet, yeah, you're right. There is like a philosophical like
By the way, yeah, but my solution to the philosophical problem is give the user the ability to specify their solution to the philosophical problem. Like you could have like a system prompt that's like, hey, this is what I consider authoritative, and this is what I don't. And then
yeah,
so you just like give full control to the user. You need a search engine that's smart enough to handle that. Like you can't Google something like, hey, like I think like WebMD is not authoritative, and I think this other thing is authoritative, and then search your query. Like you can't do that, right? But you should. And so like I dream of a world where everyone has their own customizable search engine. It's also I think yeah, and it really does get to a philosophy of like almost like freedom. It's like I
yeah,
really like people at the company really think of like if you give full control to the user to specify what they want, you are freeing them from the whatever like like whatever like ideology that your search engine like previous
yeah.
search engines had, right? So it's a pretty big deal, I think.
It's the alignment problem, but in search, I guess.
I think I think the alignment problem with search is a huge thing, and like people don't think about it. Yeah. It's
Yeah.
actually it's a nice way of putting it.
Yeah.
I,
Great.
I I do have a quick question. I can't find the hand raise on the
No
phone.
worries.
Sorry. So, what is a document for you? Like you mentioned that you're embedding, and I guess embeddings are fixed, but text is varying in length. So, do you embed War and Peace, or is there like a limit? Like, is there any chunking involved?
There is a limit. Uh, Chunking is something that's on our mind, but it's not like you could do a lot. You could do pretty well without chunking, but chunking is definitely important.
Oh, interesting. Oh, because I guess you're not working with like large PDFs. It's like a website sort of has a very natural
That's
boundary.
exactly right.
Got it. That makes sense. That makes sense. Yeah, it's like I think many people now are just like embedding each PDF page under the assumption that humans have done a good job organizing pages to be sort of relevant rather than
Yeah,
trying to like turn it to markdown first and then chunking the markdown.
right. That's funny. You can imagine an adversarial web where like the first part of the document is very different from the last part, and then like, it would be really hard to search over things. But
Yeah,
it's
yeah.
the structure of the web. I mean, a lot of these things are easier because the structure of the web is was organized by humans who are pretty reasonable.
Yeah. Lots of incentives in the past. Um, Great. With 10 minutes left, this is the question I ask everybody, which is like, what is a question you wish you like the audience asked you? Like, what is something you think has been really important that we haven't really caught up on or noticed? This is the test time compute running right now.
Right. It's just doing it's just a monkey clapping.
Actually, let me ask you a smaller question. Would you ever do Exa for internal data?
We're starting with the search over public data. I think,
Yeah.
it's hard to say how the world will change.
You're gonna enter the Glean market, but I was just
I mean,
curious.
I think there's a huge market for just like really good search over the
Yeah.
public web. To answer your question, maybe like, why hasn't anyone done this before? I mean, like that, like,
Yeah.
like what's going on here? Like, like why we're like a small startup? Like, why are we trying to like? We're talking about like reinventing search, and like, why is no one else doing it? I think like what I've realized, it's pretty obvious now, but like incentives for like the financial incentives for a company, like basically why hasn't Google doing this? Um, and I think financial incentives are ridiculously important, and like Google just doesn't make more money, like significant more money by like pre-processing their gigantic index in all the ways that Exa wants to. They are making $200 billion a year from their current approach. And it's just really hard to shift a company to like do a totally different paradigm. And I think this is like a fascinating property of companies. I'm noticing even as we get bigger, it's hard to shift the company in all sorts of ways. And like if you're a gigantic company with like
Yeah.
$200 billion in revenue from a certain method, it's like it's really hard to even care about smaller markets. But those smaller markets become, I mean, it's basically innovators dilemma. But I do think the search space is big enough where like there are lots of winners. And again, like that San Francisco going through an earthquake thing is the right vibe where it's like I think we're seeing this in the news, like the entire search space is shifting. It's unclear how the dust will settle, but there's opportunity everywhere.
Yeah, and it looks like, search APIs are literally just getting shut down now. I know, like, I spoke to some people from deep research on the Google side, and they're like, yeah, we need different search APIs. And I'm realizing it is because, they're kind of optimizing for like reciprocal rank versus whatever this new thing is, which is like, I actually want 1,000 results, or I want to do deep research with 10,000 web articles.
Right. And the space of possible searches, like we show with that circle, is so broad that it's actually
Yeah.
really hard for one company to like be the perfect at everything. So it's like bifurcating in all these ways. It's like splintering, and there's just like it's a big market for like knowledge. I mean, again, this is a knowledge market, right? Big.
Jan?
Yeah, you talked about Google not being interested in setting something up like this. So what is your business model? How is your company going to survive, the fierce competition that exists?
Yeah. So I mean, the big difference is we don't make our money from ads. We sell usage based, like per query. So per 1,000 queries, you'll pay some amount of dollars. And so our incentive is to make people like the search as much as possible, like get the highest quality information so that they use it more. Whereas Google's incentive is like making them click on ads like a little bit, right? Like they also need to keep the search high quality enough that people don't like still use it. So they're but like the optimization functions are different. And when you have these AI systems that you can optimize towards some objective, the objective really matters. Does that answer your question?
Are you afraid that some of those big companies will buy you?
Well, I guess that would be up to me to decide, but I want to see this problem through. I've worked on this problem for 4 years. Like I want to solve this problem. At this point, it's like my mission in life. So I think because we have these very pristine incentives, like we are our mission is very aligned with our financial incentives. So it's a very beautiful thing. And so I don't want to, I don't want to.
Search worth paying for, right? I think that's the thing. I would love to be able to say like, I want to spend like $1,000 on like LLM compute and $80 on like search compute to do like a report that is going to help me make a decision about what I buy or how I invest. That'd be a really exciting way of doing it. Let's do the last question, then we'll let you go, Will. Shirai?
Hey, just wanted to trying to understand more and more about IR. Came across, how would you distinguish yourself from Superlinked, actually?
From what is that?
Superlinked. This Daniel Snornova's, he worked in Google.
Oh, yeah. I think they're doing a talk sometime later in the month, but they do a lot of like encoder stacking.
Yeah, they have an encoder. They do boosting, filtering, re-ranking, all of that stuff. And so take a look. I mean, he had a talk on Maven on evals recently. So it looked kind of similar to what Exa was doing. So we're just very interested in understanding what.
Yeah, I'll definitely check it out.
And while you are here, I want to know anything you can point us to a blog post or anything about IR, latest in IR.
I mean, we have some posts on our system on Exa.ai/blog. You can
Yeah, we'll share a link at the end of like to all the attendees, and we'll include like Will's LinkedIn, Twitter, and some blog
Perfect.
posts as well.
Perfect. Thank you so much. Loved it.
Cool. Thank you.
Yeah, and then how can we stay in touch with Exa? Yeah, we'll share a bunch of links afterwards on what Exa is up to. Now I feel like I just go sort of. Oh yeah, I guess one difference I'll call for Superlinked is I think Superlinked is closer to a database.
Right.
Right.
They
whereas
are a database. They are a
Yeah.
vector database. That's right.
Yeah. Yeah, I think the question is if they can store 1 trillion records.
Yeah, things break down every time you do 10x.
Yeah.
Agreed.
I'm excited. I'm excited to hear what kind of more GPUs you start dropping millions of dollars on. Great. Well, thank you so much. I learned a lot about search. I'm actually really curious to read some of these blog posts now. Maybe I'll just email you offline and just ask for some recommended readings, and then we can share that with the team.
Sure.
As always, yeah. Well, thank you so much.
Yeah, thanks everyone. That was real fun.
For attending.
Thank you. Loved it.
Follow up in the emails. Take care, everyone.